Right, so now let's look at an example of an improper integral of type 2. Right. So we're looking at the integral from 0 to 1 of x over x minus 1. Now why is this an improper integral? Well, you'll note that the function we're integrating, x over x minus 1, is discontinuous at the end point 1. Right. So that means that we can't calculate this integral using the fundamental theorem, right? We have to express it as a limit. Right. So, that's the first step, right? We notice that this is an improper integral because the function has a discontinuity at the one endpoint of our interval of integration. Right. So, this discontinuity is at the right endpoint at 1. So we're taking the limit as t goes to 1 from the negative side. Right, and we take an integral 0 to t x over x minus 1 dx. Right, and now to evaluate this integral, right, we have to do a bit of long division. Right, and if we do the long division, right, we'll get 1 plus 1 over x minus 1. Right, so we're doing long division here, although in this case it's not very long, it's quite short. Yeah. So now let's evaluate the integral. Let's find the antiderivative. And so that'll be x minus or plus ln x minus 1 from 0 to t, and substituting in the bounds to get the value for the definite integral, we get t minus ln t minus 1. Right. So let's see what's going to happen as t goes to 1. Well, as t goes to 1, t minus 1 goes to 0. Right. So ln of t minus 1 is going to go to minus infinity. Right. So our integral is going to be, well, t goes to 1 minus infinity, right, because ln of t minus 1 goes to minus infinity. Right, and that's going to give us plus infinity, right, which means that the integral is divergent, right, because its value is not a the limit is not a finite number. Integral is divergent. Right. Let's go over this one last time. Right. Firstly, we have to recognize that this is an improper integral, right? Because the function we're integrating has a discontinuity at 1. Right. So we have to express this limit, or this integral, as a limit. Right. The discontinuity is at the top end point of the interval at 1. So we take the limit as t goes to 1 from the negative side. Right. And we take integral from 0 to t. Evaluate that, right? So find this definite integral, and then take the limit. And in this case, that limit is infinity. Right. So graphically, looks something like this. Right, there's our function. There's t, right? Now this definite integral corresponds to that area, right? And now we're letting t approach 1. Right? And we see what happens to that area. And in this case, that area goes to infinity.